All right, let's talk about confounding. This is one of those concepts that shows up everywhere on epi exams, and honestly, everywhere in real practice too. Here's the core idea. Confounding is the third variable problem. You think you're looking at a clean relationship between an exposure and a disease, but there's some other variable lurking in the background that's mixing itself into your result. And to earn the title of a true confounder, a variable has to satisfy all three criteria on this slide. Not two of them, all three. Has to be associated with exposure, has to be associated with outcome independently, and critically, it must not sit on the causal pathway between the two. My favorite example is right here on the slide. If you collect data on kids, you'll find that bigger shoe size is beautifully associated with better reading ability. Nobody thinks buying your child larger shoes will make them a better reader. The real driver is age. Older kids have bigger feet and read better. Age is the confounder, and it manufactured an association out of thin air. And notice that confounding cuts both ways. It can create a spurious association that isn't real, or it can mask a real association so it looks like nothing is going on. Both are wrong answers. So what do we do about it? You get two shots. The first is at the design stage, before you collect a single data point. Randomization is the heavyweight champion here because it distributes confounders, both the ones you know about and the ones you've never heard of, evenly across your groups. Restriction means you just limit your study to one stratum. Only adult dogs, only intact males, simple and effective, but it costs you generalizability. And matching means you pair each case to a control who shares the confounder. Your second shot is in the analysis, after the data is already in hand. Stratification, the Mantel-Haenszel approach, lets you look within levels of the confounder and then pull. Multivariable regression lets you adjust for several confounders at once. Standardization lets you compare populations with different underlying structures. Now, here's where I want you to slow down. Before you adjust for anything, draw the causal diagram, the DAG. Ask yourself honestly, is this variable a confounder or is it a mediator sitting on the causal pathway? Because if you adjust for a mediator, you are blocking part of the very effect you're trying to measure, and you'll wash out a real finding. Adjusting for everything you measured is not sophistication, it's a mistake. And finally, the humbling one, residual confounding. In any observational study, there are confounders you didn't measure and confounders you measured imperfectly. Some of that distortion always remains. That's not a flaw in your particular study, it's a fundamental limitation of observational research, and it's exactly why randomized trials sit higher on the evidence hierarchy. Bottom line for epi exams, three criteria, all three required, and C must never be on the E to D pathway. Like, share, and subscribe for more.